Welcome to the first lesson of the IB SL/HL chemistry course in R2.1. Today we will be looking at chemical equations and how to balance them. First, let's start with the law of conservation of mass stating that mass is conserved in chemical reactions. This means that the total mass of products must equal the total mass of reactants. This is evident in the visual diagram below when methane reacts with oxygen to produce carbon dioxide and water. The first thing to note is that there are equal amounts of atoms on both the reactants and the product side. Next, when we add up the masses of both the reactants and the products, they equal each other. This just proves that energy is conserved in the form of mass in a chemical reaction. Now, to balance equations, we can only change the number in front of the reactants or the products. These numbers are known as the coefficients. In the example below, we can see one atom of sodium reacting with two atoms of chlorine to produce one atom of sodium chloride. This equation is unbalanced, and to balance it, we must add a 2 in front of the sodium chloride so that there are 2 atoms of chlorine and 2 atoms of sodium. Now, since the chlorines are balanced and the sodiums are not, we must add another 2 in front of the sodium on the reactant side to balance the sodium, and therefore the full equation. Now, let's try some examples. In the first example, we have calcium carbonate reacting with hydrochloric acid to produce calcium chloride, water, and carbon dioxide. In the equation below, we can see that there is one atom of calcium on both the reactants and the product side, one atom of carbon on both the reactants and product side, 3 atoms of oxygen on the reactants and product side, 1 atom of hydrogen on the reactant side and 2 atoms of hydrogen on the product side, and 1 atom of chlorine on the reactant side and 2 atoms of chlorine on the product side. This equation is half balanced, and in order to fully balance it, we must add a 2 in front of the HCl on the reactant side so that there are now 2 atoms of hydrogen and 2 atoms of chlorine on the reactant side. In our last example, we are going to be looking at zinc reacting with silver nitrate to form zinc nitrate and silver. This reaction is a displacement reaction, and we can see that there is 1 atom of zinc on the reactants and the product side, 1 atom of silver on the reactants and the product side, 1 atom of nitrogen on the reactant side and 2 atoms of nitrogen on the product side, and 3 atoms of oxygen on the reactant side and 6 atoms of oxygen on the product side. In order to balance this reaction, we must add a 2 in front of the silver nitrate, as this will then have 2 atoms of nitrogen on the reactant side and 6 atoms of oxygen on the reactant side. However, since there is also a silver present in the silver nitrate, it will have 2 atoms of silver on the reactant side, which is now unbalanced as there is only 1 atom of silver on the product side. In order to correct this, we must add another 2 in front of the silver so that there are 2 atoms of silver on both sides. This equation is now fully balanced.